Welcome to Electricity series. Electricity is running the whole civilization. Have you ever wondered what is electricity? I connect two terminals of this 9-volt cell to two terminals of this motor and this motor runs. The question is why and how? Metal carries electricity because in their atoms, electron of the outermost cell is very loose, so loose that it can easily be displaced. When we complete the circuit, electron enters the wire and displaces an electron from outermost cell of an atom. Then that electron goes and displaces an electron from some other atom, and this cycle continues. And very soon we get a flood of loose electrons because there are millions and billions of atoms in a conductor. Electrons are charged particles. We get flow of electricity because flow of electrons. But the direction of electric current is taken as opposite of direction of flow of electron. As electricity is flow of charged particles, measurement of this current depends on how much charge flows through a cross section of wire in unit time, that is 1 second. If q coulomb charge is flowing through a cross section in t second, then electric current I would be q by t, that is how much charge passes through that cross section in 1 second. Now one electron has 1.6 into 10 to the power minus 19 coulomb charge. So for 1 coulomb charge we need 6.24 into 10 to the power 18 electrons. So much electrons. It means when we are talking about 1 ampere electric current, we are actually talking about a flow of billions and billions of electrons. Now we always hear the word voltage. That is actually unit of potential difference. Now what is that? The potential difference between 2 points in an electric circuit is the work done to move an unit charge from one point to the another. Means the potential difference between 2 points V is equal to work done to carry some charge from one point to another divided by how much charge has been carried. 1 volt of potential difference between 2 points in circuit means 1 joule of work has to be done to move 1 coulomb charge from one point to another. Now we know overhead wires has high voltage and it carries very high electric current. A German scientist named Simon Ohm found that the current through metallic wire increases if we increase the potential difference across its terminals. The higher the potential difference, the higher the current flowing through the wire. So he said, if temperature remains same, the potential difference across 2 points of the conductor is directly proportional to the current flowing through it. If potential difference across two ends of a wire is V and the current flowing through it is I, then V is directly proportional to I. Now we need a constant to turn it into an equation, and the constant here is R. R is called resistance. Now this resistance R represents the property of the conductor to resist the flow of charge through it. Means if resistance is higher, the conductor will resist electricity flow more. We know these old bulbs, it uses filament with very high resistance, as much as 1200 ohm. Ohm is the unit of resistance. Now we connect it to 220 volt power source. So from Ohm's law we get V is equal to IR, that is I is equal to V by R. We put the value of V and R. 220 divided by 1200 is equal to 0.18 ampere. Ampere is the unit of electric current. Now we take a heater. It has much lesser resistance, say 120 ohm. So I is equal to V by R, V 220 R 120. So the current flowing through the heater is 1.83 ampere. So if resistance increases, the electric current, that is I, decreases. That is I is inversely proportional to R, resistance, given voltage is unchanged. Copper, aluminum, etc. have very low resistance. For a given voltage they carry much more current. Hence, electric wires are made of these materials. And that's all for this episode. We will go deeper, but later. Thank you.